I'm Amy Elliott. I work at Oak Ridge National Lab as a scientist, and my research is 3D printing. As a kid, I didn't really know what I wanted to be when I grew up. I guess I enjoyed band. I played the flute in band and thought, okay, maybe this is the skill that I need to get a career. So it wasn't until high school that I discovered the robotics team, and my brother was on it. He got to go to a competition in the state of Florida, and I wanted to go to Florida, so I joined the team and then realized what STEM and engineering was and just fell in love. After high school, I was in college for 10 years, getting a bachelor's and then a PhD. And the reason I actually went into grad school was because I had worked really hard in undergrad. You know how it goes in engineering and science. It's a tough road. And then I'd done a lot of extracurriculars. We have a Baja team here in the States. And then we have NASA Moon Buggy and those kinds of building. The extracurriculars where you spend time in the shop, and I really, really like that. But I just worked so hard that I felt like I didn't get the student experience. And so I was like, you know what, I want to stay in school for a little bit longer, get that student experience. So I went to grad school thinking I would just get a master's, but then ended up with a PhD. And it was actually a really great decision to do that. I really enjoyed thermodynamics. I think it's because it was all algebra based, like it was like very little calculus. And I just really enjoyed like calculating enthalpies and doing that kind of thing. And then in grad school, honestly, so I really liked, I had the ceramics class that I really liked. But then my favorite class was this design of experiments class. So we actually got to learn about the Taguchi method and then orthogonal arrays. It's a really cool way to structure an experiment. So you can do as few samples as possible, but still understand what's going on in your process. Anyway, that was my favorite class because it was so powerful. I really enjoy the discovery. There are moments where, you know, things are starting to click, concepts are starting to come together, and you've discovered something that could be big, right? Or you've done an experiment and the results are just really, really interesting, and you can say, hey, look, this is really valuable information. That's what I love the most, is being able to just find something new, find something useful. When you get a patent, so I've got a few patents now, when those get licensed by a company and they're actually using that technology, that's my favorite. That's the best feeling in the world. In general, we do a lot of work with materials and 3D printing, just trying to figure out kind of what are the boundaries of the process? What materials can we print? What materials can't we print? And one of the coolest materials I think we've printed is silicon carbide, which is a really high temperature material. It's a material that's really, really hard to shape. But using our technology, we can actually shape it into a very complex geometry. And now we're talking about making silicon carbide heat exchangers, which, a few years ago would have been a bizarre thought. But now we can think about using these high temperature heat exchangers to increase efficiency on power generation, any other process where we have high temperature and we want to recover that waste heat. And maybe not as attractive as like some other 3D printed things, but it's actually really, really important. The vast majority of our wasted energy is actually in waste heat. So if we can make things like high temperature heat exchangers, we can save a lot of energy. There are so many applications of 3D printing. One obvious one is medical. So all of our bodies are different. And when you use 3D printing, you can really make a custom part that's custom shaped to your body. And then a lot of the prosthetics actually nowadays, like a hip implant or a knee replacement, especially in Europe, are 3D printed because not only can they size them and shape them properly, but they can also put texture on the surface, like a nice, we call it a lattice or a cellular structure, basically like a 3D chain link fence that your bone likes to grow into. And so that's one really cool application. They can actually extend the lifetime of the implant by putting that texture on the surface of the part. And you can only do that with 3D printing. There are actually a lot of consumer products out there. So you can go to like shapeways.com and order custom jewelry, custom figurines. Like I have my my little ring that I've designed and had printed at Shapeways. It's little here with the heart in the middle. So consumer products are big, but really I think the killer app for 3D printing is automotive. I think one day, soon we will see automotive start really embracing 3D printing for production, not just prototyping, not just tooling, but actually for production. I am surprised about how much administrative work I have. I think that goes with pretty much any job, but it's just like I felt like I would be spending more time in the lab, but it ends up being more like proposals and like, logistics around experiments. And, there's things that you have to do as a scientist that are not really science, but are part of, running a lab. And that's actually what kind of surprised me, but, it's all good. Like, I think every job has those tasks that come with it that nobody likes. So there's no like perfect job out there. Read all of the productivity books, learn all the tips, learn how to be efficient, and then learn how to prioritize. There's a matrix where you can decide if things are important and urgent, or if they're just urgent and not important, or unimportant and urgent, etc. And so you can kind of categorize your tasks that way. And then honestly, you have to give up on being a perfectionist in certain jobs, especially something that's so fast-paced like research. You just have to give up on being a perfectionist and decide that, okay, I'm going to do as much, I'm going to do this much for this, and get it out of my way. So anyway, there's a lot of different things you have to learn, but it's all part of being a productive person and getting things done. So like, it sounds like miserable, but it's actually very fruitful if you learn your system. I get up around 6 and get ready, and then I get my son ready. One of my sons, I have 2 sons. I have a 2-year-old and an 11-month-old. And then I take the 11-month-old to daycare, and then my 2-year-old stays home with my mom. And my husband's in school right now, so he kind of leaves when he needs to. So yeah, I get to work, and then I usually do a lot of email correspondence. There's a lot of things, like I said, logistics around experiments, proposals that we're writing. A lot of people inquiring about like using our technologies, so responding to that. I'm a group leader, so there's, some things I have to do for that. And then usually I have several meetings throughout the day. And then I do try to get in the lab. I don't get in the lab as much as I want to, but then, that would be the other thing that I do in the days. Organization, obviously, quick decision making, and being able to connect the dots between all the things that are going on, being able to delegate, being able to communicate. Yeah, so really, like, on top of the science, being skilled in your trade and understanding your science, also having some administrative skills. I wish I had taken more material science courses, because all of my education's in mechanical engineering, which is great, very useful. But there's so much material science and 3D printing that I've learned a lot. Like, I feel like I've done a pretty good job, catching up. But I think it probably would have benefited me to have just a few more material science courses. 3D printing works by building objects layer by layer. And so there's actually a lot of ways to do that. The most common way is to extrude molten plastic through a nozzle and then draw the shape of the layer with that nozzle. So it's kind of like a hot glue gun. So you draw a square with the hot glue gun, you let it cool, draw another square on top. If you keep drawing squares, you'll eventually have a 3-dimensional cube, and that's just how 3D printing works. The technology that I work with, we print metals. And so instead of using a nozzle and liquid plastic, we use metal powder and an inkjet print head. So we spread metal powder into a layer, use an inkjet print head to glue that layer into the shape that we want. Over and over again, we get a box of powder with glue arranged in the shape of our part. We dig it out, and then we go center it in a furnace, just like a piece of pottery, to get a fully dense metal part. So that's just two of the different ways you can 3D print things, but there's actually 7 different technology types out of 3D printing. And then in addition to that, there's a lot of different shape factors in terms of how the machines are built and how they're configured. So we have lots of different types of projects. Sometimes we do build 3D printers. And so we have our custom hardware, and that can take anywhere from a few months to maybe a year to get a full system going. We also do a lot of just prints themselves. So prints can range from just a few hours to a few days, actually. I think the longest print we did was maybe a month long. We try not to print things that long because who knows what can go wrong during that time. Power could go out, the gases could go out. Like, it's very risky. We really, really need tradespeople who know how to weld, who know how to machine, who know electrical. There's just not enough of those people. And so that's a really great career option too. If you like to be more hands-on, right? So as I said, I don't get to be as hands-on as I want to be, but those trades absolutely do. But if you're interested in STEM, I would say just explore different options, look at different topics, and if you don't find the right one off the bat, that doesn't mean you're not meant for STEM. Just keep looking. There are so many different things. I mean, almost anything that you are interested in, there's a STEM field behind. There's a lot of like really technical books about 3D printing that, you could get. There's reference books. But one of my favorite books that's kind of for the layperson about 3D printing is called Fabricated by Lipson. And anyway, it's just really good forward-thinking book about what 3D printing could be in the future. So that's one of my favorite books. In terms of productivity books, I don't have a single one, but I feel like, all of them have good information. I use the app Blinkist, where you can get just a quick synopsis of the different self-help books. And so that's how I can get through a lot of books in a short time. We still have a lot of work in the fields. One of the things that we're working on here is the digital factory. So basically having so much information about what we're printing, what we're doing, that we can qualify parts as they're being made. We can, track parts in their life use and see how they're doing and improve upon that with that information. So there's a lot of that on that digital thread that we're working on. And then for me personally, I'm excited about multi-materials. So we can do a lot of 3D printing with single materials, and that's great. But now I think we have the opportunity to print with multiple materials and really tailor material properties according to location. And I think that's really exciting. I think that's going to open up a whole new world of efficient devices for power generation, transportation, you name it.